Hi, my name is Tom Kay. I'm Head of Research and Development here at Airgun Designs, and the videotape we're making for you today will teach you everything you ever wanted to know about the 68 Automag. We hope you'll find this interesting as we're going to cover history, theory, mechanics, and hot rodding of the gun. So with that, we'll first go into history and show you exactly where we started with this whole thing. The history of this gun starts back in 1987. At that time, we were manufacturing accessory products for the airgun industry, and we started working on a prototype gun we called the Panther. The Panther was your typical blowback gun, and after 1 year of development, this is the final prototype that we came up with. This is the finished prototype of a gun we developed from 1987 to 1988. The prototype was later sold, but never manufactured. We bought it back in '89 and then continued on with further development. This gun had a single barrel design, cocking lever, short trigger pull, hidden airline. The airline ran up through the sight rail on top. It featured an anti-double ball feed spring up in the front barrel, back bottle adapter, and M16 grip. For its time, the gun was very advanced. This gun was very functional, although it didn't make the market at this time. We're sure if it did, that it would have been a big hit at that point. In 1989, when we bought back the rights to the Panther, we started developing the second gun. We codenamed this gun P2 for Panther 2. At the time, pump guns had gone through a tremendous evolutionary change, and they had added things like quick release barrels, field strip screws, instant velocity adjustment, all the things that were not true in 1987. With this in mind, we looked at our original design of the Panther, and we said that this thing cannot come apart too easily. It's a little difficult to maintain. You have to use shims to put in the washers. We took a new design approach. We said that we must build a gun that can come apart without tools all the way down to the valve. This is the crude prototype of what we came up with, and I'll show you how it comes apart. A single screw on the bottom allows the barrel to slide off, allows the frame assembly to come off, springs come apart, the valve slides off, and you can get down to the valve without any tools. Now this gun was also a blowback design. The gun you see here is not functionally complete. It's missing the back bottle adapter. But this gun did function. The problem we had with this gun, as well as the other blowback designs we worked on, was that it was very sensitive to pressure fluctuations with the CO2. The pressure fluctuations would cause a beat-down effect or a motorboating effect that would make the gun useless until the pressure came back up. Originally, this back bottle adapter was mounted on the back of this gun, and the hose came up into the side, and as the system recoiled back and forth, the hose would flex. We felt this was the most reliable interconnection between the valve and the back bottle adapter. With the advent of this gun, we realized that we were up against a major problem with blowback designs, and that when the pressure fluctuates, it's hard to get the thing to recock. So after 2 years of development of blowback semi-auto guns, we sat down and we cleaned off the drawing board and we said, okay, what do we want? We want a gun that functions consistently and reliably under varying pressure conditions that we knew we were going to find in CO2. We also said we didn't want a full auto effect. We wanted the gun to lock up on that trigger mechanism all the time. The other thing we didn't want to do is we didn't want to have to over-engineer the trigger mechanism in order to grab a moving bolt and stop it while it's moving. This puts a lot of shock loads on a trigger system, and a trigger system has to be over-engineered to be able to withstand that type of load. So we drew a matrix of the 4 different valve systems we can use and the 4 different bolt systems that we could use, and each of these interconnected in this matrix to tell us what type of gun we would put together and what type of characteristics it had. The only gun that we saw that had the type of characteristics we were looking for was a pressure-regulated blow-forward system. And that's when we developed P3, again, code name for Panther 3, and this is the original prototype of that gun. The gun we're developing now is P4. It is functionally similar to this gun. The reason why we changed the major configuration name is because there are some major parts in here that have changed that cannot be interchanged with today's guns. But the concept here was that by blowing forward the bolt, a spring would always return it to the cocked position. You would never have a situation where your trigger mechanism would not lock up. Because the spring was pushing it back, you were not counting on a trigger mechanism to lock up that bolt. So there was no stress on the trigger mechanism and allowed us to have a much easier trigger mechanism. The pressure regulator we built straight into the gun. At the time we were thinking about a pressure regulating concept, we said, boy, we know we can get high pressures going. It'd be great if we could regulate the pressure down to 700 or 800 pounds all the time. That way we wouldn't have to worry about high temperatures or sun on bottles creating high CO2 pressures and causing guns to go hot. But then we said, what about the other side of the coin? When the temperature drops, the pressure drops in the bottle, and then you have that same problem of not resetting or not getting enough velocity. So we said, well, what if we could make a gun function at such a low pressure that there would always be more than that pressure available in your tank, even if it got cold? Generally, tanks are somewhere between 550 to 1,000, 1,200 psi. So we designed this gun to run around 450 to 500 psi. That way there would always be enough pressure in the tank to ensure that the gun would cycle. And that's where we came up. So the next thing we'll do here is we'll go inside and we'll show you exactly what makes this gun function. Before we get into any discussion about the internal parts of the Automag, the first thing we have to do is describe what three areas this gun breaks down into. The first section we'll talk about is the back end of the gun, and that's the pressure regulator. That's the first functional part of the gun. The second part of the gun is right in the middle. And this is the on-off valve. The on-off valve. The third part of the gun is in the front, and that's called the power tube. In all situations with the gun, there are only three functional components to the gun: the pressure regulator, the on-off valve, and the power tube. Each of these areas is separate and distinct in themselves. They only connect with one another by air passages between the respective parts. So what you have is you have three completely separate systems that are packed into one valve mechanism. Once you understand which system is going wrong, you'll know instantly which one to go look for if you should have a problem or something should need to be maintained or replaced. So in our discussions, we're going to keep talking about the three areas: pressure regulator, on-off valve, and power tube. In the gun, all of the parts in the gun are named for their respective areas. If we're talking about one of the parts in the on-off valve, we'll say on-off pin, on-off top, on-off bottom. Likewise, with the regulator, we'll talk about the regulator piston, the regulator seal, the regulator valve. And you know that's in the back part of the gun. Same thing in the front. Everything associated with the power tube says power tube spring, power tube O-ring, power tube tip, power tube, spiral clip. So keep that in mind as we're going through. Next, we'll get right into the gun and let you take a look at all the individual parts. Okay, we're back with a stock 68 Automag that we're going to go through some of the basics. First of all, the overall construction of the gun is aluminum and stainless steel. Everything that you see is gray is made from 300 series stainless. We're one of the few guns on the market that is made from stainless steel, as it's a very durable but kind of rough material to machine and work with. We spent a lot of time trying to get our suppliers geared up to manufacture this, and we hope that you appreciate it. The gun has a removable 10-inch barrel, single piece construction. This is a level 6.6 gun. The difference between the level 5 and the level 6 guns, where the level 5 guns had this piece as a separate unit that stayed inside the gun. The level 6 guns dropped the ball directly into the barrel, and this gave us improved accuracy, improved efficiency, and reduced ball breakage. The gun slides in, the barrel slides into the gun with a quarter twist and locks in place. The back of the gun has the velocity adjustment screw. Just a very minor turn of this screw should be enough to adjust your velocity 10 or 20 feet per second. It's almost never necessary to adjust more than a quarter turn. A turn to a half a turn will throw your system completely off, and you'll be either way high or way low. An adjustment screw that's too far out will cause the gun not to cycle at all, and it'll be very confusing as to exactly what's wrong with it. This has happened on many occasions. The frame is a die-cast frame from Wargrain products. This is a stock grip. There are several optional grips available. Lapco makes a very fine grip. On the back side we have the 9-inch Teflon braided hose. Many people ask us, why do we have this hose here? It sticks out, it causes a problem. Well, we feel that this is the most reliable way to link your valve system with the back bottle adapter. The reason why we didn't do a solid link to the valve body was because that would necessitate unscrewing a bunch of screws and nuts before you could pull your valve body out. At least with this loop of hose, you can now remove your valve body and not have any fear of having a leakage problem while you're out in the field. The back bottle adapter is your standard issue. There's one hint on the back bottle adapter that we want you to be aware of. When you screw a tank into the back bottle adapter, that's fine, it'll gas up. Many people will then unscrew the tank until the point that it degasses. If you do that, you must then turn it one or two more turns before you screw it back in. If you unscrew your tank just to the point where it degasses and try to screw it back in again, you will cut your O-ring in half. So watch that. We all want to save on O-rings. Now we'll go through the gun one part at a time, and we'll tell you all of the maintenance tips and the pros and cons of dealing with that part of the gun. First thing we'll do is we'll work on the barrel. The barrel has been OD ground on the outside to allow for a slip fit inside the main body. The O-rings here are what give you that slip fit tolerance. If you like a tighter fit, what you can do is you can take off an O-ring, put a thin piece of Scotch tape underneath the groove, put the O-ring back on over it, and you can adjust your fit that way. Some people like a little tighter fit, some people like a little looser fit. We try and design in for a medium to try and keep everybody happy. The other thing you'll notice about your barrel is that it has a wire nubbin. And we'll go ahead and pull this wire nubbin out and show you exactly what it's about and how to adjust it. The wire nubbin sits in its own groove. If you take off the forward O-ring, it'll just pop right out. And this is the wire nubbin. See if you can get it close. Now you see that there is a small bend in the end. This bend is what goes down into your barrel and prevents your balls from double feeding. It's a simple matter, if you need to adjust that, to go in with a needle nose pliers and adjust both sides of the wire nubbin. So what I've done is move the point further in, but I have not bent it in like this. That would be incorrect. I bent it to maintain the V. Maintain the V, but have the V protrude deeper in the barrel. When you go to put it back in the barrel, put the back end first, in underneath the O-ring, weave it in between the slot, roll the O-ring down over it. Now what you want to do is you want to look down the barrel and see how far your wire nubbin is sticking inside the barrel. You want it to stick in there about the thickness of a matchbook cover. If you're using small size paint, it needs to come in a little further. If you're using a large bore paint, it can stick in a little less. It's one of those things you have to adjust by eye and for the conditions you're playing in. Wintertime paint generally is smaller. Summertime and high humidity, they get larger. So seasonal variations may cause you to need to adjust that wire nubbin. On some barrels, this one doesn't have it, there is an extra notch slot. The extra slot is on the left side of the original slot and has a small wall at the end. These are ambidextrous barrels. You don't have to remove that wall. You only want the one notch. If you have a lefty gun, that notch will be removed, and you can have a left or a right side feed. We do offer that as an option. The barrel is the same barrel material used for the famous butt-or sniper, long known for its accuracy. We anodize the inside of the barrel. There's a lot of pros and cons about that, but we feel that the harder anodizing will last longer. A unanodized ID of a barrel can be made smoother, theoretically, but that smooth finish will not last as long as a hard anodized ID. We do polish the anodizing after it comes back from the plater to give it the smoothest possible finish. And that's everything you need to know about a barrel. Next, we'll go into field stripping the gun. The field strip screw, as many of you recognize, unscrews out of the bottom. The first thing you must learn about your gun is that you need to pull the trigger before you pull your valve body out. Pulling the valve body out, it should come straight back and then stop. And then you must push down on the hose slightly to slide it out the rest of the way. And we see that the reason for that is we have an interlock pin here on the valve body, right where my fingernail is. That interlock pin slides in what we call the Z groove here in the corner. This Z groove is here to prevent you from unscrewing the field strip screw while the gun is under pressure and having the valve pop out back at you. It's not a very serious thing, but it's just one of the things we look for in the overall safety of the design. Once you take out your valve assembly, you realize that looking down the gun, there's nothing left in your main body at this point. Available for easy cleaning. We'll go to the bolt next. Here's your bolt assembly. Your bolt assembly consists of three pieces: your mainspring, your foamy, and your bolt. There are two types of bolts now, level 6.0 bolts and level 6.5 bolts. Level 6.5s have a small step on the pin inside the bolt here. You can't see it in the video, but if you're looking at one, you can tell the difference by seeing a small step there. If your bolt does not have a step, it's a level 6 gun. If it does have a step, it's a level 6.5 or 6.6. That's the difference. That step was put in there to promote more reliable sealing of the power tube O-ring. We won't go into the mechanics of it, but just understand it as part of our ongoing development to give you the very highest quality product we possibly can. The bolt springs. Bolt springs are made from music wire. It's a high tensile strength spring wire. This bolt spring is made from square wire. Usually springs are made from round wire. The reason for this is as the bolt flies forward, the spring collapses completely flat. And the square wire allows it to stack up evenly. Round wire wants to move inside of each other. Some of the very early Automags have got round wire springs. If you have one of those springs, just call the factory and we'll be glad to replace it for you for free. Your bolt spring may wear. If your bolt spring gets down below the front level of your bolt spring is worn out too far. We are looking for higher strength materials to make this spring out of right now. We may have found some that will be hopeful we'll be replacing this spring with a more permanent one in the future. But for now, if you have any problems, please call the factory and we'll let you know. We do have replacements available in every parts kit. The foamy in the front of the bolt has had a long evolution. Originally, we tried to use a spring, something that would be more permanent than the original foam that came out in the early guns. The springs tended to break and fall off and didn't work out too well. The foam rubber foamy was what worked the best at reducing ball breakage, and it was easily replaceable with a self-stick foam. Recently, we found a very soft, natural rubber that we're supergluing onto the front of the bolt. This natural rubber should last a season, if not more, of use if not mistreated. If you have an old style bolt, all you have to do is take off your foamy, clean it with alcohol or some nail polish remover, dry it off real good, use some super glue, and stick this new rubber foamy on, and it should last a long time with good service. The back edge of the bolt is the edge that hangs up on the sear. The sear grabs just the very leading edge of this bolt, and that's what gives you that crisp trigger pull. If you see an edge that's starting to get round, that's a sign of wear. The bolt is softer than the sear, so it's very unlikely that the sear would wear out. It's more likely that you'll see wear on the bolt. It's easier to check that out than to check out the sear, so that's why we did it that way. And that's about everything that you need to know about the bolt. Next, we'll go into the valve body. Now we're moving on to the power tube. This is the power tube assembly here. There's a bumper at the base. The bumper is there for the recoil of the bolt. After it moves forward, the spring pushes it back. The bumper hits it and keeps from impacting metal to metal and causing problems. The power tube can be taken apart by using a nickel or a penny to unscrew the power tube tip. Again, notice the name. This is the power tube tip. Inside the power tube, you'll find first the power tube spring. Power tube spring. And beneath that, you'll find the power tube O-ring. This is a 90 durometer urethane O-ring. This is the O-ring that takes the most abuse in the gun. It's also the O-ring that will freeze down if you get liquid in the gun. And a frozen O-ring here turns into plastic and will not seal. That's why it's critical to keep liquid out of the gun. We're going to go further than most people go. Most people take this, just the power tube tip and spring out. We're going to take off the bumper. And we're going to show you the air chamber. Underneath the bumper, you'll find a spiral clip. This is the spiral clip that holds the power tube in place. A little bit difficult to find, but there's an edge that you can catch with a pick. And the spiral clip will spiral out. Now the power tube can be pulled directly out. This now exposes the air chamber. If you notice, we have a very large air chamber on this gun. The large air chamber is there to give us the low pressure that we need. Pressure and volume can compensate for each other. The higher the pressure, the lower the volume. The lower the pressure, the higher the volume. Therefore, our low pressure gun has a high volume air chamber. This is the power tube base. It has an O-ring that seals the air chamber. This O-ring at the base is usually not a problem and never has to be changed. Most people will never have a need to go into the air chamber. The one thing that you should check is there's a characteristic problem if the spiral clip starts coming out of the groove. If that happens, your gun will lock up. We have found several guns that do not fire for no good reason. If that happens, take off your bumper, look underneath your bumper at your spiral clip, and see if it's working its way out of that C-clip groove. If it is, just push it back in and everything should be fine. A spiral clip that's working its way out will cause the power tube to cock sideways, and when it does that, it pushes the bolt against the barrel and then will refuse to fire. Now with the power tube removed, we'll go to the back of the gun and we'll break apart the pressure regulator. This is the valve body, this is the regulator body. The regulator body is part of the pressure regulator system that we talked about on the chart. This is the power tube, area number 1. The center section is the on-off valve, area number 2. The regulator is area number 3. So remember, these are 3 separate and distinct systems. So we'll put the valve body down for a minute, and we'll take apart the regulator. Now if you zoom in, you can see that this seal here is one of the most important seals in the gun. This seal is what regulates your pressure. If this seal is to leak at all, this will cause erratic velocity with your gun. If you get a situation where you have erratic velocity, or if you get a first shot hot, clean off this seal or replace this seal. This seal snaps in one way hard. The other way is usually easy. It comes out very easy one way. One way you have to snap it in hard. You want the seal to go in the way that snaps in hard. That way when you take the gun apart, it won't fall off in the grass and get lost. We have 2 air passages. A slotted face is an older style passage. The new style passages have a larger air hole drilled through the regulator. If you have an older style slotted face, please call the factory and we'll be glad to drill that hole out and update it for you. We have another large O-ring out on the side. This generally is not a problem O-ring, but there is one extra in the parts kit if you need it. There is also a spare regulator seal in the parts kit. Good maintenance on the regulator seal is to clean this off with your thumb whenever you take the gun apart. Microscopic dirt on this seal will cause problems. So we'll pull this off and put it aside, just so you can see how the whole gun comes apart. Now, your regulator adjusting nut is something most people don't want to go into, but we'll take it apart here. The regulator adjusting nut is put together with a special grease so the stainless to stainless threads won't give you any binding problems. Leave that grease on there, don't take it off. If you do clean it off, use some type of anti-seize compound on the threads when you put them back together. Underneath the regulator adjusting nut is the spring pack. Now this spring pack is sealed as a unit like this. These are the springs that push against the regulator piston and adjust the amount of pressure going into your air chamber. This is not meant to be disassembled. It is packed in grease just to prevent rust. This is not something you should ever have to fool around with or need to change. Going a little deeper, the next thing we can pull out of here is the regulator piston. You have to get in there and hook it with something. And pull out the regulator piston. Now this piston is what opens and closes your valve to let more or less pressure in from your tank. When the piston is first installed, we do grease it and put it in here. Many people do not clean this. You need to clean this every few months or so. Certain parts of the country happen to have a phenomenon we call dirty CO2. Many of the CO2 tanks are very old and they get an accumulation of black crud that comes out of them and will wedge this piston into the regulator body. When that happens, the gun starts getting erratic. You need to pull this out and you'll see a large accumulation of black dirt and stuff. Clean that all off. Clean it off inside here and you should be okay. Grease it lightly when you put it back together. The regulator piston has built into it a blow-off valve. This is not user adjustable. This is preset at the factory. If your regulator should fail or leak and get beyond the prescribed pressure, this blow-off valve will start venting air out the back of your gun. This is a common occurrence if you get liquid in the gun. If the gun should start blowing out the back, do not shoot the gun, let the gun vent down, or point the gun in a safe direction and fire to unload the residual pressure. If it continues, stop immediately, take the gun back, call us if you need to. And that's all the things that are involved in the regulator portion. Next, we'll go on to the valve body. This is a cutaway of the Automag valve body. The parts we have just disassembled were the regulator adjusting nut, the spring pack, which is in here, the regulator piston, and the part we didn't mess around with, which is inside the regulator piston, is the blow-off valve. The part we looked at before was the regulator seal that's right up here. Next, we'll go into the regulator valve. Take a look at that. That's in the forward valve body section. This is your valve body. In the front end of the valve body is the regulator valve. Some people say this looks like a German hand grenade. If you look at your spring will often trap different debris that's coming through your CO2 tank. So you want to keep an eye on that spring. It acts like a filter. If there's any problems with it or anything caught in that, clean that spring off when you reassemble the gun. The regulator valve pokes into the regulator body. If you look very closely, zoom in on that, and you'll see that there's a small gap between the head of the valve and the regulator seal. That's correct. That should not be touching that regulator seal right at this point. When the regulator piston moves back under pressure of the gas, that's when that valve comes in and seals. If that valve is touching that seal, you have a problem, please call Airgun Designs. As we said, there are 3 functional parts of the gun, all of them interconnected by air chambers. This air passage right here is what connects the back part of the gun, which is the pressure regulator, to the on-off valve. The air comes in from the hose through this center portion under high pressure. It goes past the regulator valve that we just showed you through that little gap into the regulator piston, where it comes back around and goes through this hole to the on-off valve. So everything from this hole back is one complete separate unit. Only thing separates the regulator from the on-off valve is this hole here. Moving down that hole, we come to the center section of the gun, which is the on and off valve. You remember from our diagram, the on-off valve is in the middle of the gun. The on-off valve has several parts, all accessible without tools. Using fingernails, you can pull out the different pieces. This is the on-off pin in the middle, right here. And this we call the on-off bottom. On-off pin, on-off bottom. If you notice, the on-off pin has a small groove that shows which end should be sticking out. Don't turn this pin around. We put this groove in here so it's easy to grab. Leave it that way. We have a urethane O-ring on the outside of the on-off bottom, and we have a Teflon O-ring embedded inside this piece. One of the things to look for in maintenance is to make sure that this pin is a little bit stiff going in and out of this O-ring. If this Teflon O-ring gets too loose, you'll get a very slow leak out the side of your gun, and you won't be able to tell where it's coming from. It's a simple matter. Just pop the on-off pin out, pull out the O-ring, and replace it with a new one. A good way to replace the O-ring is to lay the O-ring on a table push the on-off bottom on top of the O-ring. And that'll seat the O-ring. Usually, brand new Teflon O-rings are a little tight on the on-off pin. So what you want to do is you want to first push the on-off pin in from this side to stretch the O-ring out. Once it goes in, and it still has some tension, then it's easy to push the on-off pin in from the other side. The on-off pin should stay in place by itself under tension of the O-ring. As we go deeper into the on-off valve, we find that there'll be another part down inside there. That's the on-off top. If you come in a little closer, you can see that there's a crosshatch cut in that. Usually the easiest way to get this part out is just dump it in your hand like that. Now you can see from looking at this piece that one piece is cut, the other side is flat. The flat side always goes up against the O-rings in the bottom. When you look in the hole, you should always see that cross cut. That's what allows the air to flow into the air chamber. Opening these grooves up do not do any good. We already experimented with it. This is the maximum airflow that you can achieve, so don't mess around with this piece. Going back to the valve body, down into the hole where the on-off valve is, you can see two O-rings. There's a small white Teflon surrounded by a larger urethane O-ring. Also, I should point out that there's a laser engraved diagram on the front here of exactly how all these parts go back together. First are the two O-rings. Second, you can see it. Second is the on-off top, on-off bottom with the pin going in last. So if you ever get stuck, that's how you can do it. Watch that diagram and it'll tell you exactly how to do it. I'm going to reach in here and pull out these O-rings. Usually you want to leave these Teflon O-rings alone because Teflon is not like a rubber. Teflon is more like a plastic. And if you dent a Teflon O-ring, it will have a hard time sealing and you can damage the O-ring perfectly. So you don't want to be taking out an O-ring like this unless you know it's bad. Those are the two O-rings. This is the O-ring that's most likely to cause problems in the gun. And we'll show you exactly how to identify if that O-ring is bad in a later segment. So that's the on-off valve. Again, we have the on-off O-rings, on-off Teflon, the on-off urethane O-ring. This O-ring, the urethane O-rings in the on-off valve assembly are identical to the O-rings that are in the power tube. So if you need a spare O-ring real quick because one got stretched out, they won't do any good if they're cut. But if you need to try a new O-ring, you can go into your on-off valve and take one of these out and try it in your power tube if you run into a problem. When you go to put the on-off valve together, I showed you how to work with this piece. Put the Teflon O-ring in by pushing it against the table. Put the on-off pin in. Now the way I personally like to reassemble this is I put the brass on-off top on this assembly like this. Then I push the Teflon O-ring onto the pin. Now that Teflon O-ring should go on with a little bit of a tension. If it goes on too loosely, then that won't seal. Should be enough tension that the assembly does not come apart. All that leaves me with is the one urethane O-ring. So in order to reinstall the on-off valve, I put the urethane O-ring in first. It would be kind of sloppy. And then I put in my on-off valve assembly as one unit. And that pushes the whole thing into place. Voila. And that is a disassembly of the entire valve system. from start to finish. Going back to our cutaway, we've now looked at the regulator piston assembly. We know it's connected by an air passage through the valve body. That air passage connects with the top of the on-off valve. The on-off valve controls the flow into the air chamber. The on-off valve is actuated by the trigger mechanism, so when you pull the trigger mechanism, the pin pokes up through this top white Teflon O-ring and shuts off any more gas flow into the air chamber. This is what happens just before firing. Now that we've taken apart the valve body, we'll go toward total disassembly of the rest of the frame. First thing we can do is pull off the back bottle adapter by unscrewing its two bolts. Next, we'll disconnect the front frame screw. And the body comes off. Once the body is off, you can wiggle the frame off. The frame is held on in the back by a steel spring tube. So you may have to wiggle it off of there a little bit. The frame has no more parts in it besides the trigger mechanism and the safety. Make sure that your safety spring does not fall out of here when you take this apart. Now we're down to the sear that's inside the rail. The sear mechanism has several parts. First thing we'll do is we'll push it up through the rail. And we'll take a close look at it. The sear has a sear pin, which can be removed. The sear itself, which is made from hardened steel and cadmium plated for long life. And the trigger rod. Many people try and adjust this trigger rod to get better trigger performance from the gun, but that's not what it's there for. The trigger rod is just there to take up slack in the trigger mechanism. If you try and adjust this, you will just send your system out of whack, and it won't do you any good and won't improve your performance. So leave that trigger rod alone. This leading edge here, take a closer look at it. This leading edge is where the bolt locks up against the sear. If this edge is ever filed or become damaged, the sear is no good. You need a nice sharp edge on the corner of this portion of the sear. This back portion of the sear is what pushes up on your on-off valve. So what you have is you have a teeter-totter effect here. As the sear, as you pull the trigger mechanism, well, in this case you pull the trigger mechanism this way. First thing that happens is the on-off valve pin gets pushed up into the O-ring and shuts off the flow to the air chamber. The timing is such that just a fraction of a second after that O-ring closes off, the bolt lets go of the front edge of the sear here, and the gun fires. The bolt then returns, the sear hooks the bolt up, and the on-off pin comes down and lets more air into the air chamber. That's the entire sear mechanism. Back to the rail. The rail now is basically bare except for the twist lock in the front. This twist lock pin is spring loaded. You can see it flex a little bit there. That's the pin that locks your barrel in place. It's pressed into the rail. You generally don't have to take it out. There's a set screw in the bottom here that just holds the spring in there that causes it to be spring loaded. You should never have to take that apart. The main body is made from 304 stainless. There are 4 different welding processes that go into the manufacture of this main body. This main body is by far the most difficult piece to make in the entire gun, even beyond those parts that are machined. The 4 welding processes are: we spot weld this nut on the bottom. We TIG tack weld the washer into the main body. That washer is then copper brazed in a single operation. Comes back out of the oven. A TIG weld then spots the feed tube onto the main body, and it goes back into the oven to be nickel brazed around the base of the feed tube. That's before we bring it back here and sandblast it and make sure everything is right with it. But there are several types of washers that we've used in the main bodies. The latest washer is much thicker and has much more surface area to copper braze into the tube. Anybody having any washer problems, please contact the factory. Now we have totally disassembled the Automag. We'll take just a few seconds here and show you exactly what to look for when you're reassembling the gun and how to do it quickly and efficiently. We'll start with the valve body. Start with the small pieces. First, the regulator valve and the cone spring. Slide that in. Doesn't come out, that's fine. Next, we'll take the large on-off O-ring, pop that in its hole, right there. We'll then take the on-off bottom and the on-off pin. Slide the one inside the other, making sure that I have the notched end facing toward the O-ring end of the on-off. Can you see that? O-ring and notch go together. Next, we'll put the on-off top, notches on the on-off top facing toward the stainless steel bottom. And lastly, we'll pop on the Teflon O-ring. So that makes our on-off valve assembly. And that'll go right in this hole. Ready to go. Now we'll find our power tube. Power tube O-ring. Put a little grease on this to make sure it seals. Push it into the ledge. Once it's on the ledge, we'll take our spiral clip, work it into the groove, making sure that it's all the way in the groove, all the way around. Put the bumper down, flat. Next, power tube O-ring. Drop that little guy in there. Push him down into the bottom, get him seated. Next comes the power tube spring. Before you put your power tube spring in, inspect it carefully to make sure there are no pieces broken off and that it's 100% intact. What we're looking for is fairly good grind on one side. If you want, you can look at both sides of this thing, figure out which side has got the flatter grind on it, and put that toward the O-ring. In this case, they both look about the same, so it doesn't matter. We'll drop that in next. On top of that comes our power tube tip. Screw that in. Use our nickel to lock down the tip. Now we flip it back over. Let's go to the back. Take our regulator, make sure we put our regulator seat in so it's a little tight. Want the tight end to go in so it stays there, doesn't fall out. Screw the valve body to the regulator body, and we screw them together until the Automag logos line up. Everything lined up, everything looks okay. Now we're going to go to the back. We take our regulator piston that we're going to put some grease on. We've already got some grease on this, so it should be fine. Regulator piston goes in, O-ring first. Push that down to the bottom. Next we go for our spring pack. Washer end in first. That's the only way you can really get it in. On top of that, we screw our regulator adjusting nut. A quick way to adjust this is to just snug it up. That's usually close enough to get the gun to shoot. Now to this, we pop on our bolt assembly. When we do this, we check to make sure that the bolt assembly slides freely on the power tube. If it doesn't, that usually means something's wrong. So check that. Next, we put on our bolt spring, checking the length, looks good. Our soft rubber foamy is looking good. And we want to look right here. You see that little crack between the rubber bumper and the bolt? That shows that we're resting on the O-ring inside the power tube. That's correct. That's exactly what you want to see. You want to drop it on there and see that crack. That means everything's perfectly aligned and ready to go. That's our complete valve assembly with very few tools ready to go. Now let's go to our frame. Frame and rail combo. We'll pick up on our sear. Put our sear pin in. Special hole up front here that we've put in here to allow you to pull the sear in and out at will. Slide the clevis and trigger rod through that hole and pull the sear pin down into its slot. We try and make for a tight fit there. So make sure you get that seating all the way down in there. Looks good. Make sure you've got easy movement and you're fine. Since we didn't take out our twist lock body, we're just going to leave that in there. Now comes one of the trickier steps in getting the frame onto the rail. A lot of people have problems with this, but there's a very easy way to do it. What we do is we aim the trigger rod at the point behind the trigger that we want it to come out at. Like this. We want it to come out right here behind the trigger. So the easy way to do is aim like this, come down, and push it in. Now after you get it in, you should be able to push on the sear and watch the trigger come forward. You can see the trigger rod sticking out right there. That's what you want. See it moving? That's the correct position. So now we have a frame and rail mounted together. Next, we drop the main body onto the rail, making sure that it seats all the way down in the rail. Find our front frame screw. Screw that down. Make sure there's no wobble in the main body. Everything's tight. You should be fine. You should also look to make sure that your main body sits down in the valley of the rail, both in the front and in the back. It can take a little bit of, if you have a little bit of gap, that's okay. But just make sure that there's no serious problem there. Now we'll screw our back bottle adapter in. You might want to Loctite these in place. Rotate the hose up. Slide the valve assembly in. When you go to slide the valve assembly in, you want to look to line up this notch, that pin in the notch. Slide forward. Remember, it's got a Z shape to it. Push it all the way forward. And we'll put in our field strip screw. Tighten that up. Slide the barrel in. Wire nubbin is up on standard models. Locked in. Let's see if we did a good job. It's generally a good idea when you gas up the gun to hold the trigger on. What that does is it keeps all the O-rings sealed up. Gets full pressure in the gun before you try and seal everything. No problem. That's the way it's done. As we told you before, there are three main areas to the gun. Since we've taken the gun all apart, you've now been through the mechanics of those three areas. We'll now talk about what problems you can experience and what area that they're related to. The pressure regulator is what controls the pressure in your air chamber. The pressure in your air chamber controls your velocity. So anything that has to do with velocity has to do with the pressure regulator. It can only be in one of two areas. It can either be in that regulator seal or in your regulator piston being stuck. Those are the only two areas you should look in if you're having a problem with velocity. The next area we go to is the on-off valve. The on-off valve divides the gun in half. When you pull the trigger, it shuts off the flow to the front of the gun. So first of all, if you have a leak in the gun, first thing to do is fire the gun and hold the trigger on. This will divide the gun in half. That's an important concept. Now if you're leaking down the barrel and you fire the trigger and hold the trigger on, it continues to leak down the barrel, you have not divided the gun in half. That means there's a problem with your on-off valve. If you hold that trigger on and it stops leaking, that means your leak is somewhere forward of the on-off valve. So that either means it was in the bottom part of the on-off valve or in the power tube. Anything associated with leaking down the barrel is associated with the power tube. And likely, it's that little O-ring in the power tube, that power tube O-ring that we told you about. So, leaking down the barrel, power tube. On-off valve divides the gun in half. You can learn a lot by holding that trigger on. If it stops leaking, it's somewhere in the front. If it continues leaking, it's somewhere in the back. Anything that has to do with the velocity is your pressure regulator. And those are the three areas that you go to if you have problems. The on-off valve also has another characteristic that if you fire the gun and hold the trigger on, you'll get what we call a lawn sprinkler if you have a bad Teflon O-ring. The gun will go like a lawn sprinkler and only occasionally leak air. When that happens, you need to replace the little white Teflon O-ring that's down in the bottom of your on-off valve. So let's remember that. Lawn sprinkler. That only means one thing: Teflon O-ring. Pressure regulator. Velocity, what do we look at? We clean. Regulator piston. And we clean or replace the regulator seal. Those are the important points to remember. So those are your three major sections of the guns and the problems associated with each one. Next, we'll go on to showing you some actual problems and how to debug them. The first thing we'll do is we'll check this gun for problems. Tank on, gas up, everything's fine, fire's fine. First step in checking a gun: pull the trigger, hold it on. There is a problem. This is the lawn sprinkler. This is what we were telling you about, the problem with the on-off valve. We're holding the trigger on, but it's continuing to leak down the barrel. Lawn sprinkler. Teflon O-ring. Divides the gun in half. If the on-off valve is working correctly, there should be nothing leaking out the end of this gun, no matter what. So we'll go through and run a quick fix on it. Degas the gun fully before you ever take the valve body out. Strip your valve, pull out the on-off, bottom and pin, take out the brass, and in this case the Teflon O-ring came out by itself, so we'll put that aside. We'll go to our trusty Automag parts kit that has all of the rubber parts and rubber seals that are necessary to fix the gun. It has one of every rubber part that goes in the gun. Again, I'll use my favorite method of putting this together. I'll put the Teflon on the pin. It's a new Teflon. It goes on a little snug. It's fine. Check to make sure it doesn't fall off. Pull out my valve body, hook it back in. And we'll see if it fires. Fires okay. Hold the trigger on. Everything's fine. We now have a functioning on-off valve. Problem number 2. Screw on the tank. Check our tank pressure. No problem. 850. Hold the trigger on. Leaking out the back of the gun. What could the problem be? Fire the gun. The gun is hot. We go back to our chart. We know we had a hot shot. Had to do with velocity. Another thing we should add to this list is leaking out the back. Whenever it leaks out the back, that has to do with the pressure regulator. Take the gun apart and take a look and see what's wrong with this one. In this case, somebody forgot to put the regulator seal back in. Now, we did this for demonstration purposes, but you can see what would happen if your regulator seal were to be left out, or if it were to get a piece of dirt or something clogged into it. You would see air leaking out the back. So let's put our regulator seal back in. Tight end in first. Screw it back together. No more leaks. Everything's fine now. Now we'll see what type of problem this gun has for us. Gas up, hold the trigger on, release the trigger, hold the trigger on, no leak, let the trigger off, definitely barrel leak. On-off valve working correctly, leak down the barrel. Leaking down the barrel is always associated with power tube. Degas the gun. Remove the bolt. Take off the power tube tip. Take off the spring. Field trip screw is a good way to get these things out of here. See, we'll pull out another power tube O-ring from our handy parts kit. The spring in. The bolt on. And put it back together. Put a fresh tank on. Trigger on. All fixed. Now we have a new power tube O-ring in this gun. What we're going to do is we're going to force this gun to go liquid. The liquid is going to go past the O-ring. It's going to freeze that O-ring up. It's going to start gushing down the barrel. Once that O-ring gets too hard and gets like plastic, it won't seal anymore. The first thing we want to do is pull the trigger and hold the trigger on and let that O-ring warm back up. Let's see if we can get it to go. Hear it going? Now if I continue to fire, I'll continue to freeze that O-ring. But by holding the trigger on, I can let it warm up a minute. We'll force it further into liquid. Eventually the trigger mechanism starts hanging up because the liquid takes time to boil off. Now we hold the trigger mechanism on, let the O-ring warm up. We're going to try and clear out. What we want it to do is we want to get all the liquid out of the system. Next, we're going to come up with a gun that has what we call classic bolt stick. Bolt stick can happen when you're either rapid firing or when you get a drooping shot or you double ball feed. This gun is a severe example of it. Now the bolt's locked up. The only way to reset the bolt is to go in and push something against it. Watch the trigger click out. In this case, this is severe. And we're locked up. And it comes back out. This happens under rapid fire conditions in extreme cases. What we can do to check for this is take something like this piece of plastic rod, remove your barrel, put it down against the bolt, hold it lightly there, and fire the gun. When you get the gun to burp like that, if it's going to bolt stick, it'll bolt stick now. In this case, we've got it. What do you do when you have bolt stick? The first thing you do is replace your power tube spring. It's the first thing you want to do. Power tube spring pushes that O-ring back a little further, and that's what's causing your problem. Your O-ring is hanging too far forward. So let's go ahead and do this, and we'll come back and see if we can get this baby to work. All right, we replaced the power tube spring. That's the little copper-looking spring inside the power tube. You can just barely see it sticking out here. Now let's go ahead and check this gun for bolt stick. This creates high residual pressure in the gun. No more bolt stick. The bolt stick can be a combination of bolt spring or power tube spring. The thing we want you to remember that if you've got a bolt that's sticking, it's a spring, not an O-ring. It's in the power tube, either the spring or the bolt. Everything else is fine. I'm holding the trigger on. On-off valve is fine. Velocity sounds good. We're right there. Now we're on to our favorite section, the performance tournament guns. We have with us today Tim Gavin, otherwise known as Sandman from Team Swarm. He's one of the fastest triggers we've ever recorded. In certain strings, he's recorded up to 9 shots per second with an Automag. He's not using his gun today, but he's using another gun that we've set up for tournament use. And what we're going to do is we're going to have him fire over a packed Mark III chronograph, which times the time period between the shots. And we'll give you a little review to see what he's doing. Ready, Tim?
Yep.
Okay, see if we can get this.
Yep.
He fired 18 shots in 2.54 seconds. So he's not quite up to top speed today, but we'll do a review of his shots. Shot number 1, 1.7. Number 2, 0.16. Number 3, 0.13. Number 4, 0.13. 0.15 indicates a 7 shot per second, about 7.5 shots per second. He had 5 shots off in a total of 0.73 seconds. 6, 7. So in 0.98 seconds, he had 7 shots off. A little over 1 second, he hit his 8th shot. Coming up on 2 seconds, 1.97 seconds, he got off 14 shots from the beep. Get back to that end. 17 shots in 2.4 seconds, 18 shots in 2.5 seconds. That's what an Automag is all about. The gun that Tim was using today was a modified Automag. This Automag is aptly titled Little John. It belongs to John Dale, president of Airgun Designs. It features a crown point barrel, power feed, extended hose. The extended hose is used to keep liquid out of the system. If you fire downhill, the loop in the hose does not allow liquid to come up any higher than the level of the tank. The long hose also gives a longer expansion period for the CO2 to warm up before it enters the valve, preventing freeze down of the valve. The power feed we'll talk about is an interesting addition to the Automag. It was developed here at Airgun Designs to solve a very specific problem. With normal semi-auto fire, balls will tend to bobble up and down the feed tube. There's a certain amount of residual pressure that exists when the bolt comes back and opens up again, and this residual pressure comes up and will bobble the balls in your feed tube. What we've done to prevent any ball bobble is put a 90-degree bend right at the feed chamber by having what we call the power feed. Now the power feed has an additional bonus which we'll explain to you on the board right here. Under normal circumstances, a ball will be in the chamber and several balls will be following it down the feed tube. The air blast tends to bobble these balls up. With the power feed, we have a right angle feed with the plug. And the balls move down and make a right angle bend before they enter the chamber. Now what happens are the ball bobbles up and instead of going up the feed tube, it ricochets off the back wall of the power feed. Now there's an extra timing advantage here because as the bolt is retracting, the ball is bouncing off this back wall and actually ricocheting into the chamber. So what you get is you get the energy that's normally wasted in throwing the balls up the tube gets reversed and throws the ball into the chamber. And that's how you get a very fast feeding mechanism. We don't sell it as a standard option because it does block your sight picture over the top of the gun. It's not for everybody. It's only for heavy users. Your long ballers and your guys that shoot more than 500 rounds of paint in a game are a good candidate for this feature. The power feed has been one of our most innovative developments here at Airgun Designs, and we're very proud of it. And it's used by a large majority of the tournament players that we sponsor and tournament players that are running the 68 Automag. The other improvement that we've developed here at Airgun Designs is the crown point barrel. The crown point barrel is a muzzle brake that transfers the ball from the barrel to the air over a greater distance. If you've ever been shooting, you notice that the balls come out in a straight line, but then they tend to hook at long distances. But there's quite a percentage of balls that come out and kink directly out of the barrel. And we're always wondering why that was that happened. Well, we theorized that the large still air mass outside the barrel caused the ball to wobble when it entered the air mass when it left the barrel. So we said, well, what if we could transfer the ball from the barrel to the air over a greater distance? In other words, make the barrel fade away, what we were looking to do. So we put the V notches in here, and the barrel just fades away from the ball and gives it a nice, gentle transfer into the air mass. If you were to fire a ball or a bullet or anything into water, when it makes the transition from the air into the water, that's when you'll get a kink in its trajectory. Once it's all the way in the water, a bullet or a ball would tend to go straight. But it's that transitory period between the two mediums that causes the problem. We feel that this is an improvement based on the fact that the still air mass is going to wobble the ball on the way out. An additional bonus is the V's are designed like the NASA duct commonly found in the side of Formula One race cars. What happens is the airflow will roll out of the V from the inside of the barrel out. And this is an interesting aerodynamic phenomena that allows you to have flat ducts on the side of race cars and ducting that pulls air out from inside of the barrel on the crown point barrel. Most of the guns that we have in here for updates and upgrades are coming in here for the combination power feed and crown point barrel. One of the performance options you do want to consider if you're using a tournament level Automag is some type of a hose system that will keep liquid out of your gun. The other thing we do is we have an anti-siphon tank that puts a steel hose in your tank that would come up and touch the tank at the top position of the tank when it's screwed in. You notice this tank is screwed in all the way. If we were setting this tank up for anti-siphon, it would have to be set up specifically for this gun. An anti-siphon tube must be installed by a qualified dealer. But no matter which way you would tilt your tank, the liquid level would always be below the intake of the steel tube, which would be touching the tank wall on the inside right about here. And this allows you to fire in any direction without fear of getting liquid in your gun. We also have several other performance modifications for the gun. This is the tournament velocity adjusting cap. This is a cap that screws on over the tournament velocity adjuster. And this is done so you cannot adjust your velocity on the field. You would normally adjust your velocity, screw this on, and tighten it down. There are also several other performance accessories available for the Automag. This is something you've probably all been hearing about. This is an Airgun Designs nitrogen system. This is the same thing with a smaller shot size capacity. These tanks fill with high pressure nitrogen at about 2,500 psi. The tanks are rated at 3,000 psi. They're aluminum cores with a fiberglass wrap. A pressure regulator on top of the tank regulates the outgoing pressure from this valve that goes to your gun to about 800 psi. This is a high pressure fill port that takes a special fill station to fill off nitrogen. This gauge acts like a shot counter. The gauge starts at 2,500 psi, and in the case of this tank, it has about 400 shot capacity. You would know when the tank got halfway to 500 psi, you would have about 200 shots left. To fill these tanks up, they do not require weighing. All that needs to be done is have a transfer fill similar to a scuba tank, where you fill it up to the tank pressure that you're filling from. For safety's sake, there's a 3,000 psi blow-off disc built into the regulator and an overpressure vent system similar to the Automag in the pressure adjustment screw on the back. Both of these systems should be available in 1992, and we'll be looking forward to seeing this type of performance at tournament level. With nitrogen or with compressed air in these tanks, there's no fear of liquid or freeze down and no temperature pressure fluctuations, which allows you to play under all weather conditions, hot or cold, winter or summer. Should be a major advance for the industry, and we're looking forward to it becoming widely available. Some of the other things we offer for the Automag are a slide-on sight rail, and this is a high boy sight rail. If you have a tall enough scope mount, you can get your scope over the power feed. So this is a very popular option with guys with power feeds. Also, we have different lengths of hoses available. Depending on type of conditions you want to play in, a lot of people like to go with longer hoses. For severe winter use, good success has been had by using a 2 to 3 foot hose coiled like this that's hooked up to the side of the gun. Generally, they'll run them on some type of a L-stock configuration with a coil of hose. Again, this is CO2 related. You need to find a way to keep liquid out of the system at all costs. We include a view loader with the 68 Automag because we feel this is the best feeding loader on the market. This is the new clear polycarbonate cap and has a lifetime guarantee. If you ever break one, send it back. The factory will replace it for free. This is a 100-round capacity loader. View loader has graciously let us experiment with this prototype. This is a 200-round loader, and it has a built-in electric agitator that agitates the balls. This is a prototype. There will be a finished version on the market very soon, probably by the summer of '92, that will have an LED sensor in the neck of the loader that'll tell when balls have jammed. When the balls jam, the sensor will tell the motor to start turning automatically, ensuring a continuous feed, even with a packed 200-round loader. Just the thing you need for a power-fed Automag. We also have other models available. This is the Minimag. It's a vertical front bottle version of the Automag. It features a quick disconnect coupling on the sides for no external hose, an extended main body with venting for that assault pistol look, still has a removable barrel, and a vertical front bottle. Internally, it's the same as the Automag. In addition to the Minimag, we have the gun that we call the sidearm. This is a police and military training pistol. It's the first holsterable semi-automatic 12-gram pistol. It holds 8 shots, which are spring-loaded in the clip. A 12-gram cartridge screws into the front, and the gun is ready for police training. This is a new product that will be out in limited quantities in '92. And that's some of the models that we have here for you at Airgun Designs. Accessories for the Automag include everything you see on this table, including power feeds, vertical front bottle adapters, tournament caps, shorty barrels, crown point barrels, extended sight rails, various length hoses, auto lube, view loaders, both 100 and 200 round, nitrogen systems, speed stocks, parts kits, which are highly recommended, and of course the famous 68 Automag t-shirts and Airgun Designs patches. Please contact your dealer or call us directly if you'd like one of these options.
Take 5. Action.
Don't. You're yelling in the middle of it, man.
Sound. Talk for a bit. Hi, my name's...
Hi, this is Crazy Tom and it's Crazy World of Paintball.
Under that
I'm
thing.
General Knowledge and the Cranium
In
Commando.
the thing.
How does this work?
Now.
Am I receiving? Would I like to receive?
7. Take 7, put it up, dude. Take 7. Action. Alright. Pull it out. Sorry.
Dennis, stop laughing!
Anytime. What happened there?
Great balls.
This is our Minimag, take A1.
A1.
Minimag.
Ready?
Action.